The molecular basis of all life is mysteriously asymmetric, only using molecules on one side of what should be the equivalent mirrored pairs. The universe has a similar mirror asymmetry, and it may be that our very DNA inherited its twist from the underlying handedness of reality. Hey everyone, a couple of quick announcements before we get started. We're running our next algorithm experiment for the next couple of episodes. Our algorithm has shied away from sharing our episodes with the full Spacetime community again, so we're trying to determine whether likes or comments are more influential. For this phase of the experiment, we want to see what happens if we can get 60,000 plus likes per episode. If you want to be a data point in this experiment, just hit the like button and of course feel free to comment as per usual. Finally, we have our July merch available. This is a special one. Retired scientist Dr. Jim Slater is a fan of Spacetime and the creator of this incredible image of how the Earth and the Sun moved through the galaxy. And he gave us his blessing to put it on a t-shirt and sweatshirt, so you can show everyone in your local patch of Spacetime a scientifically accurate movement of the Sun and Earth. We also have two new black hole logo Spacetime caps, one with a white hole and one with an all black hole. Links in the description. Our universe is beautifully symmetric. For the most part, the laws of physics work the same if we swap left with right, positive with negative charge, and even the future with the past. But there are subtle violations to these symmetries. For example, a perfect mirror reflection of our universe would work very slightly differently. This asymmetry is thought to be the reason why our universe is made of matter rather than antimatter, and we've talked about it before. But there's another violation of mirror symmetry that is much closer to home. Many of the most important molecules used by life are exclusively from one side of the mirror. For example, the DNA helix always curls one way and never the other, and the amino acids and sugars used by life are never used by life in their mirror-reflected forms. The reason for this still isn't known, and there are several competing hypotheses. Today, we're going to look at the idea that the handedness of life is connected to the fundamental mirror asymmetry of the universe itself. We'll focus on a paper by Naomi Globus and Roger Blanford that proposes that this asymmetry may have been delivered to Earth by cosmic rays. But before we get to the cool physics and space stuff, let's do some biochemistry. Okay, so something is chiral if its mirror reflection can't then be rotated to perfectly match the original. Your hands are chiral because your left hand can't be rotated to match your right. Molecules can also be chiral if their mirror image versions are similarly non-equivalent. By analogy, we label chiral molecules as either left or right-handed, although the assignment of the label for each molecule is somewhat arbitrary. These mirror image forms, called enantiomers, are chemically similar but can behave very differently in biological systems. Sometimes only one enantiomer is biologically active. Sometimes one is medically useful while the other is dangerous. For example, the right-handed enantiomer of thalidomide has anti-nausea properties while the left-handed causes terrible birth defects. This chiral bias is even more profound for molecules that make up living organisms. For example, life only uses left-handed amino acids and right-handed sugars. These molecules join together to construct DNA, and so the resulting helix only winds one way. We say that DNA is right-handed, as is all RNA. In principle, you could build a perfectly stable organism with all molecules having the opposite handedness, but we never ever see that in nature. This uniform selection of a single handedness across biological molecules is known as homochirality. The homochirality of life was discovered at the same time as the chirality of molecules, back in 1848 by a young Louis Pasteur. He found that crystals of synthetic tartaric acid came in two distinct mirror image forms, while those from natural sources like grapes only displayed one form. These crystals even rotated the polarization of light in the opposite direction to each other. We now know that these mirror image forms are due to the mirror image enantiomers of tartaric acid, and that life only produces the right-handed version of it. A century later, the Miller-Urey experiment further demonstrated this divide by showing that under simulated prebiotic conditions, amino acids and other organic compounds form spontaneously when simple compounds are hit with an energy source, but always as a 50-50 mixture of chiralities, what we call a racemic mixture. But in life, only the right-handed amino acids are formed and used. The Miller-Urey experiment was meant to approximate the conditions of the Earth, pre-life or prebiotic Earth, that is. The primordial soup on that Earth surely started out as roughly racemic, but life that sprang from that soup was homochiral, or at least the life that survives to this day. So when and how did that homochirality emerge? We don't know exactly how the first life formed on Earth, but we're probably safe in breaking it up into 3 phases. In the first phase, we have only simple organic molecules like amino acids, and these are still monomers. They haven't yet formed complex polymer chains. This is the world simulated in the Miller-Urey experiment. Following the lead of the authors of the paper we're about to get to, we'll call this the prebiotic phase. Then we have the phase with increasingly complex molecular chains with emerging abilities like autocatalyzation and self-replication. RNA is the prime candidate for the molecule driving this phase. Technically this is also prebiotic, but again, following the researcher's lead, we'll call it transbiotic, the transition between prebiotic and the upcoming biotic phase, which is everything after the development of the first very simple single-celled organism, the first true life form. At some point during these development phases, the stuff of life became homochiral. Perhaps, for example, the primordial soup ended up with a significant excess of one chirality of amino acid, or maybe homochirality emerged in the transbiotic stage with one winding of RNA winning out over the other, or did pre-life evolve in parallel in both chiralities all the way to the first cell? There's no known process to wholesale wipe out one chirality. All proposed processes at best give one side a small numerical advantage. So in order to achieve full homochirality, this advantage needs to be amplified via positive feedback loops that can lead to exponential domination of one chirality until the other is wiped out. Example mechanisms include autocatalysis. The chiral molecule promotes chemical synthesis of its own kind, or anti-catalysis. The opposite chirality is suppressed, or just self-replication. More and more material is locked into one chirality, starving out the other. Auto and anti-catalysis are potentially possible as early as the prebiotic era, although the known mechanisms for simple monomers don't seem efficient enough to achieve full homochirality. But once we get to the transbiotic phase, with the complex molecular machinery enabled by, for example, RNA, catalysis mechanisms and reproduction could and probably should lead to homochirality, as long as one chirality has an adaptive or numerical advantage, and this should happen very quickly given the exponential nature of the process. This would probably lead to complete homochirality long before the first cell formed. But we've yet to explain how that advantage first appeared. There are some non-fundamental options. It could be that Earth was seeded with amino acids that already had a chiral bias, brought by comets and asteroids. Those in turn could have picked up that bias due to polarized light selectively destroying one enantiomer. There's disputed evidence of this chiral bias in meteorite material, although it's hard to tell if this stuff was contaminated by the very biased Earth amino acids. This chiral bias could also have arisen right here on Earth. For example, there have been experiments with magnetite that find a kind of cooperative feedback between chiral molecules and magnetic surfaces that could induce homochirality. Or perhaps selective absorption of one enantiomer by the mineral surfaces where these molecules were stewing in the prebiotic era did the same thing. Another pretty reasonable possibility is that the advantage to one chirality was random. Perhaps one side gained a slight numerical advantage just by random chance and this snowballed, or perhaps one side reached an important adaptive step first. For example, the first RNA molecule just happened to be right-handed, and again snowballed from there. In this case, the winner of the chirality race would be completely random. But we promised to try to link the mirror asymmetry of life to something more fundamental, and so let's do that. The chiral asymmetry of the universe is most clearly manifest in the weak interaction, and this is how physicists have tried to connect it to the homochirality of life. One possibility stems from the fact that the two enantiomers of a chiral molecule have different stabilities. Atoms are bound into molecules mostly by the electromagnetic force, and the weak force, being true to its name, contributes of order 1 part in a quintillion of the binding energy. On its own, this 10 to the power of minus 18 difference in stability wouldn't be enough of a seed to push Earth's pre-biochemistry to homochirality. But Abdus Salam, one of the co-Nobel laureates for electroweak unification, proposed a mechanism for enhancing this difference. If amino acids formed in extremely cold environments, like the outer solar system, they could enter a superfluid state in which the less stable chirality gets converted to the more stable. These could then be delivered to Earth by the comets and asteroids I mentioned earlier, with enough of the weak interaction-induced chiral bias to then snowball to homochirality. But there may be a way to extract the handedness of the weak interaction without so many steps. This chiral asymmetry manifests most strongly in particle decay products mediated by the weak interaction. For example, when a pion decays via the weak interaction into an electron or a muon, the magnetic moment of that resulting particle is always in the opposite direction of the particle motion. And this handedness of decay products gives us a new way to impose the handedness of the universe on all of life. And the delivery mechanism will be cosmic rays, high energy particles from energetic space phenomena like the sun or supernova explosions. When a cosmic ray arrives at Earth, it collides with other particles in the air, creating an air shower. The kinetic energy of the cosmic ray is converted into new pairs of particles that cascade into more collisions and more particles, just like an accelerated collision. At Earth's surface, you are receiving a constant radiation dose from cosmic ray showers. In fact, the cosmic ray radiation dose is an important variable that sets the mutation rate in life on Earth. While the bulk of the particles end up as electrons and photons, the atmosphere does a good job filtering them out before they get to us. It is the rare and highly penetrating muons that are responsible for about 85% of our cosmic ray radiation dose, despite being only 1 to 2% of the particles generated in the initial shower. As high energy radiation, these muons can break up molecules. But the ability of muons to dump energy into a molecule to break it depends in part on the relative chirality of the muon and the molecule. So if muons have a chirality preference due to the fundamental asymmetry of the universe, this can be translated into an evolutionary pressure against a particular molecular chirality on the early Earth. The paper by Globus and Blandford tries to estimate the strength of the effect and whether it's strong enough to initiate the cascade of homochirality. They used computational models to approximate the damage caused to different types of chiral molecules based on these polarized muon passages. Although they're not full quantum mechanical calculations, they have models for simpler chiral monomers like amino acids and helical polymers like RNA that lets them understand how the difference in ionization can lead to molecular damage. The difference for monomers like amino acids was very small, indicating that significant movement towards homochirality is unlikely to have occurred in the prebiotic era. But they found that the difference for helical polymers like RNA was much stronger. left-handed RNA is preferentially damaged, and perhaps by enough to initiate the path to a right-handed RNA world in the transbiotic era. At least give it a strong enough rate of cosmic ray muons. While muons make up a large fraction of the cosmic rays that reach the ground, it's questionable whether there are enough to initiate a chirality snowball at the current levels. However, the cosmic ray flux changes over time. For example, nearby supernovae can dramatically increase that flux. We see geological evidence for supernova source cosmic ray spikes from more recent times. We know that star formation and so supernova activity must have been higher when the Earth first formed, giving more chances for cosmic ray spikes. It's also true that the Sun was more active when it was younger, which means more solar cosmic rays at just the time when they're needed to kickstart life. So this is a lot of speculation, but we are scientists and so we want to find tests. The molecular inhabitants of the pre- and transbiotic Earth are long gone, and with them any record of non-homochirality. But this hypothesis that homochirality originates from the chiral symmetry of the weak interaction does make a dramatic prediction that we can maybe test. It suggests that all life across the universe should have the same handedness. We should never find mirror-reflected life. If we do, that's bad news for our chirality being cosmically ordained. We should also probably not try to shake hands with that mirror life. It'd be socially awkward and a potential biohazard due to those mirror pathogens that we have no defenses against. But the alien test is probably a very long way off. If we could ever perform it at all, that is. But there's something that we can try much sooner. We can look for chiral biases in amino acids from space. I mentioned that there's disputed evidence of this in meteorite samples. Well, we need pristine samples to make sure that they are free of earthly contamination. We've also found amino acids on comets, but haven't yet been able to test for chiral bias. If we find that these molecules are always biased to left-handed enantiomers, it's evidence of a fundamental bias. If we see different biases in different samples, then it might suggest a less fundamental source, such as polarized light. When we finally get samples from the subsurface oceans of the moons Europa and Enceladus, well, maybe we'll just find life there. But if we only find amino acids, that's still exciting. A measure of the chiral bias of those will tell us a lot about any mechanism for the amplification of that bias. A significant bias would actually be a point against the cosmic ray hypothesis because we expect the surface ice of these moons to stop those muons. On a similar note, if we ultimately determine that Earth life started at the bottom of the ocean, as has been proposed, that's another ding against the muon hypothesis because the ocean stops muons. Muon-sourced chirality must have started in tidal pools, where it's exposed to cosmic rays. If you were paying close attention when we flashed the paper earlier, you might have noticed that it was from 2020. So we caught up with Dr. Globus for this video and asked a few questions about what's new. So right now, they are doing new experiments at the ISIS neutron and muon source, blasting both left and right-handed RNA with beams of spin-polarized muons to measure reaction rates and see how the biochemistry responds. We might know a lot more about the origins of life on Earth in just a few months. These experiments are also going to fill in key gaps in our models for understanding radiation effects on human health. After all, particles breaking your DNA is one of the main ways that radiation kills us. So yeah, astrophysics is saving lives again, which is a nice consolation prize even if we don't find out why all of biochemistry is one-handed. But personally, I'm hoping that the invariant winding of my DNA really is connected to the deeper broken symmetry of spacetime.